In this video, I will show you how to solve a system of equations when one or more of the equations is a conic section, meaning a circle, an ellipse, a parabola, or a hyperbola. In this first example, we have a circle and a line. When you solve a system, what you are really doing is you are looking for the intersection points. So if I have a circle and a line, then I'm looking for the intersection points between them. For number one, I think I will use substitution. Whenever I do substitution, I like to write the two equations side by side. It just helps me organize my work, and I recommend that you do the same. So I've got y equals negative x plus 4. Because y equals negative x plus 4, I can take negative x plus 4 and substitute it in for y in the first equation. So then the first equation becomes x minus 1 squared plus negative x plus 4. All right, that's my substitution. Minus 1 squared equals 4. So I've got x minus 1 squared plus negative x plus 3, combining like terms, squared, is equal to 4. I need to solve this for x, so let's go x minus 1 times x minus 1 plus negative x plus 3 times negative x plus 3 is equal to 4. If I multiply these two together, I'm going to get x squared minus 2x plus 1. If I multiply these two together, I'm going to get x squared minus 6x plus 9 is equal to 4. So combining like terms, x squared and x squared, so that's 2x squared. Negative 2x and negative 6x, that's negative 8x. 1 plus 9 is 10, and that's equal to 4. Time to subtract 4 from both sides. So now I've got 2x squared minus 8x plus 6 is equal to 0. I'm noticing that all of these are divisible by 2. So I might as well do that. So now I've got x squared minus 4x plus 3 is equal to 0. Alright, that just makes the numbers more manageable. Now, this is probably factorable. So x squared is x times x. 3 is 3 times 1. If I make them both negative, they will add up to negative 4, and negative 3 times negative 1 gives me positive 3. So this is how it factors. Now I can find the solutions by setting each of these equal to 0. So I get x equals 3 and x equals 1. Okay, so these are the x values of my solutions. So it's kind of like this. Imagine this is going to be my solution set. So far, what I have is 3 comma something and 1 comma something. But that's half a point. I need the y values to go with these x values. So the way I'm going to get the y values is by using this little equation right here. Okay, so let x equal 3. Alright, that's our first x value right there. So let's let x equal 3. Then what we have is y equals negative 3 plus 4. So y equals 1. So if x equals 3, y equals 1. So that is the y value that goes with 3. 3 comma 1. Now let's let x equal 1. Okay, then I have y equals -1 plus 4. So that's going to give me y equals 3. So these should be my final solutions. Now let's check Desmos.com to see what this looks like. So here we have our circle being intersected by the line, and the intersection points are 1, 3 and 3, 1. Alright, example 2. Again, we have a circle intersected by a line. So I need to get y by itself. I mean, I guess I could get x by itself, but I'm going to go ahead and get y by itself so that I can do the substitution. So that means I'm going to need to divide everything by 2. So if I divide everything by 2 right now, I'm going to get y equals 3 over 2x minus 13 over 2. So I can take this and substitute it into the first equation. Alright, I hope I have room. So I will have x squared plus y squared. But that's going to be 3 over 2x minus 13 over 2 squared is equal to 13. Is equal to 13. So I need to square this. So this is going to be x squared plus, and I will have 3 over 2x minus 13 over 2 times 3 over 2x minus 13 over 2. This is looking pretty ugly, but I'm going to stick with it and see if this is doable even though it is ugly. So I'm just foiling this. So if I multiply these two together, I'm going to get 9 over 4 x squared. I'm just doing 3 times 3 and 2 times 2, so that's 9 over 4. Okay, so I multiplied that, so now I'm multiplying this times this. So that's going to give me, let's see, 3 times 13, alright, and this is going to be negative, whatever it is, but 3 times 13 is 39, and 2 times 2 is 4, so I've got 39 fourths. Okay, x, and then looking at these two, that's going to be the exact same thing, so minus 39 fourths x. It doesn't look like I'm going to have enough room. I'm going to have to move this over. Okay, 13 times 13 is 169, and then again over 4 because of the 2 times 2, and this is all equal to 13. So combining my like terms, I need to combine these x squared terms, but I need like denominators for that. So I'm going to multiply the numerator and denominator by 4. Now these are like denominators. So 4x squared over 4 plus 9x squared over 4 is 13x squared over 4. Okay, or 13 fourths x squared, whichever way you want to look at it. If I combine these, I'm going to get negative 78 fourths x, and then I've got the rest of it, plus 169 over 4 is equal to 13. Now right about now I'm noticing that all of these have a denominator of 4. That makes it absolutely irresistible to multiply both sides of the equation by 4. In other words, I can just multiply everything by 4 because that will get rid of all of my fractions, alright, which are very awkward to deal with Okay, so then I will be left with 13x squared minus 78x plus 169 is equal to 52. And then I need to subtract 52 from both sides. So that's going to give me 13x squared minus 78x plus 117 is equal to 0. Now, for all I know, this is factorable, but these numbers are sufficiently ugly that I would rather use the quadratic formula. So, understanding that this is A, this is B, and this is C, the quadratic formula says that x will equal the opposite of B. Okay, so that's going to be 78 plus or minus the square root of b squared minus 4ac. So that's negative 78 squared minus 4ac all over 2a. Well, 2a, that'll be 26. The part underneath the radical is called the discriminant. Alright, this discriminant turns out to be 0. So the square root of 0 is just 0. So that means I just have 78 over 26, which is simply 3. So x is equal to 3. So look, if I'm building my solution set, then what I have so far is 3 comma something. I need the y value to go with it. So the way I'm going to get that y value is by using the other equation. So let's let x equal 3. Alright, in other words, we're substituting 3 in for x. In that case, y is equal to 3 over 2 times 3 minus 13 over 2. So y will equal, well, let's see. Understand this is like 3 over 1, so I'm going to get 9 over 2 minus 13 over 2. So y is equal to negative 4 over 2, which equals negative 2. So that is the y value that goes with this x value. In other words, my solution is 3 comma negative 2. This is the final answer. Alright, let's take a look at Desmos and see how the intersection of this line and the circle came out to be a single point. Boom! Check it out. You got the red circle, the blue line, and the intersection point is right here. Alright, for some reason it won't show the intersection point like it normally does, but it is here at 3 comma negative 2. That is clearly where the two meet. For example 3, we have 2 circles and we need to find the intersection of them. Now I'm going to take advantage of a coincidence that I see. Do you see that I have negative 25 here and then I have positive 25 here? If I were to add 25 to both sides, I will have x squared plus y squared is equal to 25. Now I have all of this equal to 25. So in other words, both equations equal 25. If this equals 25 and this equals 25, then the circle A expression must equal the circle B expression. So because they both equal 25, they must equal each other. So I'm going to go ahead and make that equation. So in other words, x squared plus y squared must equal x minus 5 squared plus y plus 5 squared. So I need to get rid of these parentheses. So I'm going to do x minus 5 times x minus 5. And I'm going to do y plus 5 times y plus 5. So double distribute or FOIL, whatever you want to call it. I'm going to do one step in my head. I hope you can keep up. Negative 5x and another negative 5x, that's negative 10x. Multiply these, you get positive 25. Similarly with the y's, I'm going to get y squared plus 10y plus 25. Might as well combine like terms over here. So I've got x squared plus y squared is equal to x squared minus 10x plus y squared plus 10y. So the like terms are 25 and 25. So I'm going to go ahead and just say plus 50, because why not? So the thing I'm really excited about is we have x squared and we have y squared. So if I were to subtract x squared from both sides and subtract y squared from both sides, then all of those cancel out. So I have 0 is equal to negative 10x plus 10y, plus 50. Okay, so all of these are divisible by 10. That makes me want to go ahead and divide all these by 10. So I'm going to get 0 is equal to negative x plus y plus 5. Okay, so I'm going to go ahead and get y by itself. So I'm going to add x to both sides, and I'm going to subtract 5 from both sides. So I'm going to have x minus 5 is equal to y. Obviously this cannot be a final answer because I still have x and y, but what I can do is do some substitution. So keep this in mind. Y equals x minus 5. So do you see right here where it says x minus 5? Well, I could put a y right here because y equals x minus 5. So if I do that, then this becomes y squared plus y plus 5 squared is equal to 25. Interesting. So that's y squared plus, and I could do y plus 5 times y plus 5 is equal to 25. So that'll be y squared, and if I multiply this out, I'm going to get y squared plus 10y plus 25 is equal to 25. So that's going to be 2y squared plus 10y plus 25 is equal to 25. If I subtract 25 from both sides, that's going to give me 2y squared plus 10y is equal to 0. This can be factored. Well, maybe I should look at it this way. First, I'm going to divide everything by 2 because these are both even. So now I've got y squared plus 5y is equal to 0. Now I have a common factor of y. So if I pull out the GCF of y, that'll be y times y plus 5 is equal to 0. Now I'm going to set each of these equal to 0. So I've got y equals 0, and I've got y plus 5 equals 0. This is an answer of its own. So subtracting 5 from both sides, I've got y is equal to negative 5. So I have these two values of y. So if I were to begin to set up my final answer, here's what I would have so far. Something, comma, 0, and something, comma, negative 5. I have these two y values, but I need the x values that go with them. How can I get those x values? Well, looking back over here, I have this little equation. So what I could do is take these y values, substitute them in, and get the x values. So let's see what happens if I do that. I think I'll use green. So let's use a y value of 0. Okay, let y equal 0. That's going to give us x minus 5 is equal to 0. Add 5 to both sides. That gives me x equals 5. So if y is 0, x is 5. So that is a point. Y is 0, x is 5. That's one of my solutions. Okay. Now let's let y equal negative 5. So this equation becomes x minus 5 equals negative 5. If I add 5 to both sides, I get x equals 0. So y is negative 5, x is 0. And that's it. These are the solutions to the system. Now let's check Desmos.com and see why these are the intersection points of the two circles. Alright, take a look. So we have the red circle, we have the blue circle, and they intersect at these 2 points, 5, 0 and 0, negative 5. Alright, these are the exact solutions that we came up with by hand. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.